Yo, good morning. I'm just gonna jump right in today because I have a lot of things I wanna manage. I wanna get done today. So it's reflection related. We're currently in the process of reducing artifacts, and we wanna reduce artifacts on the edge of the screen, or it's actually when we have something like this, when we reflect this bed right here, it's outside the screen, so we don't have any data for it. And instead of just having a cut here, we want to fade it out, and we want to fade it out based on this rectangle we see here. So that's what we are in the process of doing right now. We're working with a 0.1 distance in the x direction, so this one right here. Then we correct it to the y-axis as well, and then I want to get a gradient between here. I want to get a nice gradient going from 0 here to 1 here. And what I'm seeing now, it seems like we have, I don't know if it goes, I would like to have a more gradient, or a broader gradient here. It goes from 0 to 0.5 pretty quick, and I wonder why. So let's go with x here. Fuck it, let's go, x. So we get the x value for the screen that it is between 0 and 1. We do 0.5 minus whatever this is. So for instance, for 0.1 we get 0.4, then abs. For 0.9 we get minus 0.4, but then we have abs. So the smaller this one is, the closer we are to the edge. And then we add the 0.1 here. Because we want to compare it with 0 basically. But yeah, so this value is between 0 and 0.6, and that's the inverse lerp we do here. Between 0 and 0.6. Let's do this. Return lerp. I want to lerp from red to blue with A. Let's see, how does this one look? Fuck yeah, I think this looks like a pretty good gradient apart from whatever is going on here. This one bothers me a bit. Okay, so we're not moving as slowly in the y direction. And that's because we add a bigger value here, so we probably want to do, we don't want to do max. Let's see. See, I want to do this. Float x is equal to this. Float y is equal to this. And that's to return x. Yes. And y. Okay. And then I guess we want to do x is equal to inverse lerp 0.5, 0.5 plus 0.1 x. Y is equal to inverse lerp 0.5, 0.5 plus, and then we want a screen ratio here, and y, and then return max. Is it max I want or min? Max. Then we get something like this, and let's say that this one is a, so we don't do the inverse lerp here. Much better. Okay, this we can work with, because the idea is then that let's see. I would probably like to do 1 minus here as well. So, and if we do return a is bigger than or smaller than 0.1. Okay, fucking beautiful. So basically what we want to do is we want to use this result and we want to multiply it with the reflection value. But this result is going to be the alpha for the reflection, right? So whatever we get for reflection here will be multiplied by 1, and then the closer we get to outside the screen, the less the reflection will be visible. I wonder okay, can we clean this up a bit, because it's pretty rough right now. I think we're gonna do this. Float. We had a variable, I just don't remember what we named it. Reflection drop-off distance screen space. So we do float. Reflection multiplier drop off reflection drop off multiplier threshold. And I actually want to make this a float 2, because we're going to do float 2 is equal to this one and this one, but multiplied with this. So now we have the x and a y here, so we can do, we want to change this. Yeah, we want to change this one and this one. We want this one to be reflection drop of threshold dot x, and then this one and this one we want to be reflection drop of threshold dot y. A little bit cleaner, but still not perfect. We can probably do How messy would it be to have these calculations here? Let's do it. I wonder, or actually, let's see here. Do I want to put this into a method we can use? Or in a utility file? Blend, helper function, lighting, util math, util random. Let's keep it as X. And here we want to do float, reflection, drop off, multiplier. And yeah, let's return that one right now. I want to test it. So what do we have? B. We're going to skip all that. And we're going to skip all this as well. Okay, let's see if it works. What do we have? Reflection, drop-off distance in screen space. Yeah, there we have it. Although I wonder... I think it's good. Let's do this as well. So instead of returning instantly here, we want to store whatever value we get here, and current point SS. Do I dare remove these safe stops today as well? That would be nice. Step count, yeah, we should be able to. Get some performance. Okay, we don't want to return this one here. Then I wonder, we can probably do these calculations a little bit down the line. So let's hear bool reflection found is equal to false. Current point SS. Let me just do this, put this one here for now. So reflection found. Current point SS, we use it here as well. We define it here. Yeah, we're probably gonna do this. Step length, T offset, depth offset. Previous point, we don't use these anymore. Endpoint SS. So let's just do float to current point SS. And then we use that one here. And here. So instead of doing return here, we just want to do break. But before we do break, we want to do reflection found is equal to true, break, and then we get down to here, and we want to do if reflection found else. Okay, so if we don't find a reflection, we want to do these checks. So if ray is if the end of the ray is within screen bounds and ray is in front of whatever we have in the scene, then we sample the texture there. But we probably want to do this. We can do it like this. Reflection found. Nah, we want to do reflection found is equal to reflection found, or this, I think. So if this one is true, it's still true. If this one is false, we check this, and then we do if reflection is found, we do something. If reflection is not found, we just return infinite ray end color, which is going to be the skybox eventually. If reflection is found, however, we want to calculate this. So reflection drop-off multiplier, and then we want to do we pretty much want to blend the reflection with this one as the base color. So return blend util blend source alpha 1 minus source alpha. Yes. float for reflection color. Scene texture dot sample like this, but we're actually going to take this and put it up here. So reflection color, then we calculate these, and reflection drop-off multiplier. Instead, we're just going to do reflection color dot A is equal to this. And then we'll return a blend between reflection color and infinite radiant color. I think that's how we want to do it. So right now we have initial step through with big step distance. We take the point of interest, or the first interesting point after the lazy step through, and we double check that one. If we find a reflection there, we do this, or if this is true, otherwise we do this. Let's see what we have. Previous pointer says okay. Interesting. Reflection color float 4. Scene texture sample, scene texture point clamp sampler, current point SS. Oh. Okay, so it's the blend that screws it up. And what the hell, we still have this. That is not good. Oh, yes. Because if we don't want to do it like that. We want to do it if reflection is not found and these are true. Then we want to do reflection found is equal to true and current point SS is equal to ray.end SS. I thought Oops. This solution, or this right here, got rid of the bleeding. So why doesn't this one? Here we just return this color without doing anything else. Current point. Instead of returning the scene texture sample, we do reflection found is equal to true, and we break if reflection is not found and raised within screen bounds. Now we do true. We don't need to break here. We could also do very interested in how we got back this artifact. That's quite weird. Oh, we actually have this one here. Okay, that's good to know. Fuck it, I want to try. Huh. So if we just return this sample here, it's okay. But instead what I want to do is I want to break out of this while loop. We set reflection found to be equal to true, then we break out of it. If reflection is not found, but this one is true in this case, so this one is false. Ah, of course. Yeah, so if this one is true, this one is false, we don't do this. Then we get down to here, and we just do... We sample the scene texture and we return it. So what the hell happens between this line and this line such that this one doesn't return the same result? Huh. Yo, what's up, Luke? Another live stream of shader code I can't understand, question mark. It's definitely going to be shader code, but hopefully we can shed some nice light on it. So this result is good. If we don't return this one here and we just set reflection found to true, then we get this bleeding here. That's not good. Yo, what's up, Tar? How are you doing today? Reflection does current point change? No, it shouldn't, since we do reflection found is not true. Reflection found true. We go back to the loop. This one is false, so we exit the loop. Or we don't re-enter the loop. This one is true. Tar doing well, nice here. Same here. Same here. Is there some branching or anything that I don't understand here? bleed. No bleed. Just an early return here. Yes, okay. I think it's this one. Because if we would just do, I forget, let's do this and this. Ah, we still get it, so it's not this one. If it's not this one, it makes even more less sense. We don't use step count, we don't use end count after this, we don't use safe stop after this. Current point. Could it be? Could it be, yes, that we never entered this one, so current point is the previous current point. We do this, but here we set current points to Ray and SS. And yeah, it's not this one. I'm gonna read with this in the background. Appreciate it and good luck with the reading. Okay, when we have implemented this reflection solution, we have come across a few weird things. Eventually, most of them is some minor error I've done. But this one, dare I say it, it's probably the weirdest one yet. Ray and SS. If we take a look at this, how it was previously, is Ray and within screen bounds, Ray is Ray and in front of scene Ray. And then we'll do Ray and SS here. or it doesn't really matter what it was before. What we know for sure is that if we just return scene color here, we don't have any problems whatsoever. And if we do return scene texture here, then we get this. But actually I want to try this without returning it here. Yeah, it's definitely... Okay, I think I get it. I think I get it. It's not that weird, honestly. Fuck, it is, because it's not this block right here, it's something that happens here. If it was this one, I would understand it. Do we have a problem with current point being 0, 0? Okay. Okay. Scene texture. Okay, we have a flickering issue as well. But not with that check. Fuck, I'm dying to find out what I'm doing wrong here. Just need to make sure that we don't have any compiler mismatch or something like that. That it doesn't recompile between the commenting and uncommenting this. That's not the case. Reflection found. Yeah, something is fucked with this one. Definitely. Could it be I want to do this. Hopefully we won't crash. Safe stop. Okay. Max steps. What do we have on max steps? Plane. Max steps 1024. Yeah, something tells me 230 FPS. 230. Float for test is equal to 0001. And let's return test here. And we do test is equal to test is equal to black, test is equal to so we set it to black at the start of each loop. We set it to black, but if we get to this one we set it to white. And we should also exit the loop. So we do exit the loop here in the correct way. There's no doubt about it whatsoever. Right, set it to black, set it to white. Just return test. So that means that current point doesn't change after this. Issue unless No doubt the weirdest problem so far. Reading the what this issue what I think it stems from is that we read the scene texture sample from the wrong screen space point, but this one doesn't change after this fact. Unless we have Yo, what's up, Cooler? Are we watering successfully? Not yet. Yeah, I'm wondering if I'm... Yeah, I think the logic is correct. I think it has to do something that we exit early. Like, I think that's the most important part. I don't know, something with... Could it be a memory issue? I don't know. Break. Could we step through too much here? Max, we don't want to go min. Max steps. So step count and end count is... Oh. Depth threshold first pass. One, two. One, 0.1. I'm pretty sure we just want one here either way. Step length. Step length, yeah, we don't use this one anymore. 10, 1. Yeah, we probably just want to do but that shouldn't really matter, I don't think. I just want to double check. It wasn't a problem with t being bigger than 1. Return 0. And it wasn't a problem with return 0. It's not a problem. Let's see here. Okay, it's not a problem with those two checks. It's just a problem with exiting early. I mean, we could do all of these calculations earlier and use it in here and return, but then that means that we would be doing these calculations for fuck it, let's just do it like that for now. I find this problem extremely weird. So let's just do sample reflection color. Yeah, we don't want to do. In fact, do we want to use Ray Start SS here? No, I don't think so. We want to use Point SS. Or no, we want to use Ray Start SS. No, we want to use Point SS. Yeah, we do. Reflection color, so let's do float 4 reflection color is equal to sample reflection color. So here I'm just going to do, let's see here, reflection found. Skip this one. Skip this one. So here we return, instead we return blend. And then sample reflection color current Point SS and infinite ray end color. So we just return this, reflection found, we don't have that one anymore. So we do this. Yo, what's up, Derek? No problem at all. Hope work went well, or is going good. So what we want to do here is return blend source alpha 1 with source alpha sample reflection color ray.end SS infinite ray end color. Okay, let's see if this works then instead. So we do exit early here and do the blending here, then we do the blending here if it's needed. Reflection found. Yeah, we might want to remove that one. Yes, okay, so now we're back at this problem. I just want to try and do... Let's see what kind of result we have if we do return reflection color here. Do we have the bleeding? No, we don't. Okay. Beautiful. So what we want to double check now is this. We want to get rid of this, or we want to blur this basically. So we're doing a ray that hits here, reflects up to here, goes outside the screen. We can't really do anything about the missing reflections here, but what we can do is we minimize the alpha of these reflections. We like gradually decreasing them. And that's what I'm trying to do here, but the blend here, the blend screws it up because we set the alpha here. Blend source alpha 1 minus source alpha. Source alpha times source RGB. Oh yeah, never mind. We're getting the correct result, or sort of the correct result. Our reflection drop-off distance in screen space is 0. Which means that this one returns, or this one is 0. So when we do the blend, this one is 0. So we get 0, 0, 0 here, plus this, but then we use the destination alpha. So we want to do this one, I think. This one becomes 0, that's for sure. But then we add I want to see what happens if we increase this one. Okay, if we have 0, it gets fucked. Okay. But this is pretty much what we want to see. So when we go off screen, we want it to be like this. But we have a little bit problem of, do we need to saturate this one? Do we need to saturate it? Not entirely sure I know why it would be. And if we saturate it, I wonder if we can do... We can use this one instead. Okay. Yeah, there we go. Beautiful. I wonder if we want to transform it a bit, if we want to be... Maybe we don't want it linear. I want to see what kind of result we get if we do... This one definitely looks better than this one, I think. Let's go 10. Okay, I just want to do one more test with this one. What if we have a sphere that we put... So instead of having something like this, we would have... It looks pretty good with sphere either way, but... 0.02... Oh! Interesting. Zero point 0.02. Okay, yeah, did I fuck up Yes, I did. Dot x, dot y. So if we see this, we only get this. Okay, yeah, I think I'm happy with that. So let's see. We added this function. We don't need this one anymore. We set the current point here. I think we can skip that as well. T end, do we use this one? No. Current point SS float 2. Float 2. Okay, anything else? We changed something around here. Fixed this step length. Okay, I want to commit this because that's one more thing done. But before I do that, I think we have just want to get rid of some of these. I have a lot of garbage from previous implementations laying around. So before I commit it, I just want to clean it up a bit. A lot of these we don't even use anymore. Step length bounds. Yeah, we use this one, but we don't use... Do we use step length? I don't think so. Step length, bound, step length, nope. Array max distance, we use it here. Still want to keep that one around, I think. Max samples, no. Although it might be a better name than max steps, but nah. Max steps, max ray distance, step length bounds, infinite ray and color, artifact reduction variables. Here we have a lot. Depth threshold first pass, based on distance first pass. Okay. Second pass. Depth threshold. One sec. Okay, stride we don't use. Jitter we don't use. Final depth threshold fill range we don't use. Segment thickness. We use it for T offset, which we use for T min, and max, which we use for min depth VS, which we use for depth bounds, which we don't use. One sec, yeah, we do this right here. I think we just want to do T. So it's T offset segment thickness, wasn't it? Yeah. And then we have depth thickness, which we use for depth offset, which we use here. So this one is good, but we base it on array R depth thickness. So this is pretty much final depth threshold. What do we have at depth thickness? 0.1, 0.3. Yeah, 0.1, 0.3. Initial depth threshold bounds, final depth threshold, infinite depth ray threshold. Yes, reflection drop-off distance, screen space. Yep. One sec. Yeah. And then we have test A. I'm gonna leave that one for now. And let's see here. I think we have some unused stuff still here. Previous depth VS. And this one we use. Current depth VS we use. Previous depth seen. Current depth seen. Yeah, we don't check this one because we always have true here. D is Yes. I just want to fix this one up as well, and then we're done, I think. Best intersection step count, smallest depth difference. Let's see here, D. Come on. Yeah. But we're gonna fix one more thing here, I think. We break here. Yeah, we still want to do these. Can we check? Best intersection step count, smallest depth difference, step count, depth difference. So let's just do. We should be able to do this, right? So if depth difference is bigger than 0, we always do this, but then if this is also true, we break. Pretty clear, pretty straightforward. Okay, so this one. So I'm just gonna call the commit. I'm gonna let me just commit this real quick and we can continue on to the next issue. Let me also do this before I commit. So we take plain, copy material properties, and paste. What do we have? Okay. Add reflection, fall off for reflections close to screen edges. What do we have? 105. Okay. We're not going to do this one right now. We're not going to do this one right now. Not this one. Okay, so it's pretty much this one, and this one I want to do. We're going to start with the easiest one, which I think is this one. So it's pretty much just sample reflection color. We're going to add in a additional an additional multiplier here, and that multiplier is going to be based on so how far away from the camera is the thing we're trying to we're going to reflect. So sample reflection color, we need to send in depth here as well, and the depth we want to send in is the scene depth. But first I'm going to do it like this. Artifact reduction variables, reflection drop off. Yeah, we're going to do, I think we're going to do it like this. Header. Oh, what is the word I'm looking for? Reflection intensity. Reflection intensity variables. One sec, I usually like to add, yeah I do, space, yeah. Okay, because then I want to add reflection, drop off, distance, view space. I wonder if this makes any sense. Maybe. And I wonder if I want to base this off on so the lower and upper bounds, if I want those to be the near and far plane. That's probably what we're going to do first of all, because then we can have this as a float between 0 and 1. But nah, I don't think we want to have a drop off close to the camera. We only want it to be far away from the camera. I think. But so we're gonna have this reflection drop off based on distance let's just write it like this for now, but what it's actually going to be is it's going to be a multiplication, it's a multiplier which we multiply, let's see, we want 1 here. But that means these are going in the opposite direction. That's not cool. Let's leave it like this for now. I want to multiply this one with far plane basically, and then we're gonna take and do a inverse lerp on the view space depth. So it's gonna look like this: float depth view space. Or we can do point depth in view space. Sample reflection color, so now we can, let's clean this up by doing this and this, and we're gonna add a second parameter here, and it's going to be current depth, no, scene depth vs here. I don't think we have any other choice than to do linear eye depth, sample scene depth, ray.end ss c buffer params. Right now we don't do anything with this one, so let's see. I'm gonna call this screen bounds reflection intensity multiplier screen bounds. Is equal to this one. And then we do float reflection intensity multiplier view distance is equal to, I think it's inverse lerp we want to do, and basically I want it to be saturate. The last parameter here is going to be point depth VS. So we want it to be 1 if it's close to 0. And I want it to be 0 if we're close to the far plane, which is so projection params Z. But then I also want to use the reflection drop-off distance view space. So like this, we can probably fit this on one line. I think this is what we want to do. So reflection color dot A is equal to, or we just want to multiply it with these very long names. Okay. Okay, let's see. So right now it's 1, so we reflect no matter how far away it is. Let's duplicate this one and 10, 10. Yeah, we got some. We get some artifacts because we haven't really solved that problem just yet. But that's okay. But just to highlight, I want to do 0.3. Depth threshold second pass 0.1. Okay, so we're going to base this one on distance from camera eventually. Yeah, it's gonna be real clean, but okay, I just want to test this one, so how big are we gonna have to go eventually? Plane 1, 2, 3, 4, 5, 6. Okay, this one doesn't get. So put 5, 6, 3. And we're gonna have to do one other check eventually as well. I wonder, can we make this one big? Let's worry about that later. But we have this one. Let's do it like this, and then we do, if we drag this one down, okay, I think our far plane is at 1,000. So when we get to around 100 from the camera, we start fading it out. That's probably okay, 0.1. So if we bring this one even further back, yeah, the reflection starts being removed. Ah, beautiful. Probably the first reflection related thing we implemented that just went painless. 0.1. Yeah, and then we had 0.3 here. Although Yeah, this one we definitely want to change or improve upon. So the further away we are, the bigger it is, but 0.1 works. In fact, am I being a little bit... Okay, it might not have gone as painless as I thought. And the distance we are using seems to be... Yeah, we're getting fade out already here. But that's not based on this one. It's based on... this one... Okay, interesting. Whoa, 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 whoa. Is that just because... Okay. It's just because of the fact that... Yes, we don't hit it as much. Interesting. Fuck, so maybe I need to do depth threshold second pass. Maybe we do want to fix this one right now. Honestly, but it shouldn't be that hard. We want to base it on distance from camera. Fuck, I want to rename these as well. But before we do, I'm gonna commit this because this one is in the bag. And let's see here, max steps, ray max distance, step length bounce, infinite ray and color. Okay, let's commit this. Oh yeah. Copy material properties. There we go. Fuck. Why am I not getting a git change in this one? That's weird. What if I do 20? Okay. I'm just gonna leave that one be for now then. Let's add, or let's commit this. So add reflection follow for reflection close to screen edge. Add reflection fall off for reflections far from the camera. Related to 1 on 5. Okay, good. So let's change the second walkthrough depth threshold based on distance from camera as well. Otherwise we're going to get this blur effect, even though we don't want to get it, pretty much. Not blur, but fade out effect, I would say. So we want to change final depth threshold. We want to change this one to be bounce. C1, and then we use it here. So we want to do depth difference float depth threshold is equal to lerp and once again we can go with let's do like this. Final threshold bounds and I want to add a second one here. I want to add final depth threshold max distance maybe. Is equal to 1,000 So then we do depth threshold is equal to lerp between, in fact, do we have a lerp like this, by the way? I just need to check. Math would be real nice. It would be nice to have, I need to commit this one as well. So methods like this, we have max. We can send in a float 3 and we do max like this. That's pretty nice. I wonder if I want to have inverse lerp log with base. I wonder if I want to have something like this. Float lerp float 2 float t. Or will this obscure things? I was thinking that we do a f2 or a lerp f2x f2y t. And then I would probably have nice to have an inverse lerp as well, like that. Maybe we can skip the lerp, but we do inverse lerp min max value so depth threshold we lerp between depth threshold bounds dot x final depth threshold bounds dot y and then inverse lerp, but then we don't even have a float 2 in this case, so yeah, maybe I can use it in the future though. zero max distance, and here we want current depth VS. And as always, we probably want to saturate this one as well. And then we use this one here. Bounce. Okay, so what do we have now? So previously we had something like 0.01 this. Pretty good reflections here. If we change this one to 1, we don't destroy these, right? No, I don't think we do. We could even go lower here, I think. 0. Maybe not that low. Ah, 0.01 is pretty good. 0.01, but then we want to improve this. And let's see here. Do we have some reflections for this big sphere over here? Yeah, we do, but it's not that good. So if we do this, we get a little bit more. And if we check this one, compares 0.01 and 0.1. It's a little bit more, not that much. Do we destroy difference here? It's probably better if we go 2, 3, 4, 5, 6, 7, 8. Okay, we change this one to 1, 2. Yeah, I'm happy with this result as well. What happens with this? 2, 3. Now we start destroying it a bit too much. This one isn't helped that much, but if we do 30, 40, 50, yeah, we probably want to change this one as well. Or I'm a little bit annoyed at this result. I think I know why we're getting this. It's related to this one. So we're gonna hold on that one. But let's see here. If we do 0.1 to 10, 0.2 here, or 1. 1 doesn't give us that good of a result here. 10 gives us a pretty good result here. I don't know if I like what I'm seeing here though. At some points it's a little bit better, but if we go 5 might be okay. Yeah. Okay. So that is adding these, changing and adding, and then we just do an extra calculation. We do an extra lerp and inverse lerp here for each iteration. I think I'm okay with that. Although This annoys me a bit. And that's, yeah, that's us going on, only doing it from one direction as well, I think. Or is it? We should definitely be able to reflect this one. I'm wondering if it's... if we get a hit at... yeah, I think it's the wrong entry point here as well, because yeah, it is. So we're gonna fix that later as well. I wonder if we want to do... This one bothers me because we should be getting in from the wrong direction here, but for some reason we get this one here as well. I need to look into this one. Okay, but this one is done. So let's commit it. And then I think we're gonna do add outlines to reflections. Little bit worried about this one. But it should be okay. I need to double check one thing, but yeah. Let me just see if I can commit this material this time. Copy material properties, paste. And we're gonna do, so what is it? The final, yeah. Calculate final depth threshold based on distance to camera. This one we have done, by the way. Base more properties, camera on angle. Okay, let's do this one. So I think we can do this by replacing, or we're gonna have to do a few things, but one of them being replacing anytime we sample the scene depth, we want to sample the outline depth instead, because I think the outline depth blend output with scene color, that's not what we're doing. We're doing this. So we have outline alpha in R, and then we have depth in green channel. And what we do here is, if outline is bigger than 0, we do pixel depth max. Otherwise we do pixel depth. But so we just do sample scene depth here. Yeah, so I think I'm pretty sure we want to read this depth value instead. So I'm going to start by doing that. And initially we should roughly have the same result, although yes, here we have another thing that makes this a little bit more complicated. We can have a case where a ray hits an outline that has an alpha of 0.5, and then we pretty much want that ray to continue and get whatever is behind it. This would be way easier if we actually had the outlines and scene color blended into one texture. The reason we don't have it is because we want it to work a little bit different with the when something that is outlined is within something else. Yo, what's up, Drail? I'm at work, so I'm more in a lurk mode right now. I appreciate it. The title of the stream seems really interesting. Thank you. Have a great coding session. You too, if that's what you work with. Otherwise, have a great work session. And I recommend, a little bit biased, but I recommend my YouTube channel as well later on. So, if we have the texture split up, it's still doable, but it's gonna cost way more. It's gonna be way less optimized. Ooh, I think I got it. Maybe. Or fuck do I? Or am I overthinking this right now? Maybe I am. No, I'm not. So let's think about this case. Where do we want to? Yeah, we don't even have the correct outlines here currently. Oh fuck, we do. But not here. And this is easily fixable, I think. But we do want the outer outlines here as well. Okay, let's start by adding these outlines, the outlines around the foreground object. We just need to reconstruct outlines here pretty much. So when we return pure screen space reflection, sample reflection color. So here we get the reflection color. That's where we're gonna have to do, let's see. We're gonna have to do one more blend, one more read. Fucking outlines, man. Hello Canon, I just did. I just muted real quick and said it. I promise. These goddamn outlines are gonna make me insane, I think. So let's see, let's just check the different kinds of, I don't think I can even draw this. Let's see if I can show it here. First of all, we need to reconstruct outlines here. So this is outlines that are, belongs to this object, but is outside of the object. This object that renders right here doesn't know anything about those because they are not in the depth texture. So we render on top of them right now. So they are removed. So this is the easiest one. We just, when we return the color here, we just need to do a blend with any outlines if we have them here. The other type of outlines is, okay, here. So if we hit the character and we reflect part of the character and we have an outline on that character, that's easy to fix. We're gonna get that for free basically. But what about outlines outside of the character that we want to reflect? If we hit those during the reflection, we are gonna get we're gonna get a hit at the outline, The problem being that these outlines can be on top of an object, but that just means I think we should be able to just read whatever color we have behind that outline. I don't think we can we have a case maybe this is detailed enough that I won't care about it, but could we pretty much have a reflection ray that goes through an outline with an alpha of 0.5, continue onwards and hit something else. But if we do, I think it should be okay. We should be let's just start doing it, see what we get. So I want to start by doing, we can do, it's gonna all become very apparent once I show this. So we're gonna return infinite ray and color. Yeah, so let's do another function as well. Sample reflection color float sample reflection color float 4. Okay, so sample reflection color is I think we should hide, and we should pretty much put this one, we should put the blend inside of that one as well, because this is part of the reflection, right? So yeah, it is. But so is this. Can I do I guess we can do it like this. Sample reflection color point SS, point depth VS, bool hit. If no hit, return infinite ray and color. If we have a hit, we return blend source, reflection color, and infinite. Now here, if we get to this point, we do it's this thing as well. We can probably do return sample reflection color ray and SS. Sample reflection color. Okay. We need to do one more thing here. We need to do when we return this reflection color, we want to check, did we hit an outline in front, i.e. did we hit, is it this pixel? Do we have an outline at this point? So we need to sample the outline texture. So let's reintroduce it. Outlines, sampler outlines. And then we do float for outline data is equal to, let's use the new one then, outlines dot sample outline sampler. Yes, we want to define it the same way. Let's remove these. Texture 2D outlines sampler state. we do point SS. So now we have the outlines data. What we want to check then is we need to send in one more thing, because point SS here, that's the point of the reflection hit. We don't care about that one right now for the outlines. We're going to care about it soon when we calculate some other stuff. So what we want to send in here is basically this one, which we currently don't use. Might want to rename this one later on, but pixel UV, pixel UV, pixel UV. We're probably going to need to we're going to need to sample the outline data a lot of times, but yeah, whatever. So if outline data dot R is bigger than 0.0, i.e. we have an outline at the current pixel, then we want to do one sec, I'm not so sure we want to do this in here, because no. Sample reflection color. This is not part of the reflection color. This is part of whatever we're going to put on the reflection color. So, and later on when we will move all of this into a separate function, we want to keep it like isolated and simple, so it's only going to be reflection. Because so if we take the case where we're going to use these reflections with the water will handle painting the outline on top of the water. So here we're just interested in what the reflection returns. So for this one we're going to do this. We're not going to send this in here, and instead we're going to do, for now I'm just going to add a function that is called float4 apply foreground outline, and we're going to have float4 reflection color, and then we want float2 pixel UV. We'll read outline data. We check if this one is bigger. We still want to do this. At the end here we want to do return let's do it like this. In fact, do I want to do a compare with 0.0? That might be risky. But I do love to exit early. Otherwise we want to do util float4 reconstructed outline is equal to float 4 outline color multiplied by I'm gonna double check how we reconstruct it in procedural water. Don't we do it here? Okay, so we actually reconstructed S outline color. Oh yeah, of course, because we want to chromatic aberration and shit, but still here we have it. Yeah, it's just a simple reconstruct like that. Outline color RGB, outline color dot A times outline data dot R. Reconstructed outline, so what we want to return here is a blend source alpha reconstructed outline and reflection color. I think that's about it. Apply foreground outline. What a mess. We might as well. Yo, what's up, Diligence? Okay, let's see if this works. Unidentified declaration, outline color, yeah, we still need to... Fuck, I really need to move this into its own... We want to include it like this. Util outlines, basically, but... Okay, now, great. Now we have the correct outlines here. We can compare it real quick by doing... it's not quick, but we could do... We lose half the outlines here. And we gain it back here. And we can see and we can see here that the outline overlaps the reflection as well. So this is a reflection, and you can see part of the reflection behind the outline. That's beautiful. So now on to the harder issue to solve. We can start by just adding the outlines to these objects, or to the... I wonder how much this is going to mess us up. We can see here also, like, our outline shader and outline solution in whole. The closer it is to the camera, the thicker and more alpha to the outlines. The further away, the thinner and less alpha. What I worry about is, this is a detail we can probably skip on low-end hardware, but we might want to have it on high-end. This point right here, if we would have had an object honestly, I wonder if I'm just gonna skip caring about this for now, pawn it off to future me, because with the current ray tracing or reflection solution, I'm wondering, let's do this. Let me just visualize what I'm afraid of. Let's do sphere. Let's remove sphere collider. And let's make this one a little bit smaller. 0.1, is that too small? Yes, I might be worrying for nothing. Nah, probably not. And then we bring it up a bit. Yes. So this outline right here, when we reflect this outline, it's going to end up here in front of this one. Does it matter? No, I think we're okay. Duh. Nah, the outline we're gonna reflect here is this outline. And this outline doesn't have anything behind it. So by default we're just gonna return a bluish outline, which is gonna overlap this reflection with some bluish hue, which is ugly and wrong. Instead, what we would like to do, and I hate this, is we hit this one, it's an outline, but it's not an object, so then we want to continue and find an object, which is going to cost a lot. Yeah, we might want to handle that. First of all, I'm just going to start by skipping that information. So pretty much when we reflect this point here, we're going to reflect an outline, but not what's behind the outline. So we will cut off some of the sphere here, and it might not be that visible. But then again, yeah, maybe we can skip it. Let's see here. Add outlines to reflections improvements. Handle outer outline see-through reflection. I should get what that means. So for now, we're going to keep this simple. So if we hit an outline, we reflect it. Although I think it's going to look... Yeah, we could choose to add the... Yeah, if we hit an outline and it's not an object behind it, we're just gonna add the infinite outline, infinite reflection color to it. if it's an object behind it, we take whatever that color is. Okay. So what we're looking for here is when we do depth scene, where do we have it? Depth, I think it's called scene depth VS. Or actually, let's do sample scene depth. We do this in 4 different. This one is ray and in front of scene. Yeah, all of these we want to replace with outlines data, basically. So I wonder how much this will screw up the correction that the second pass does on the first pass, if the first pass might be returning. Oh, in the first pass we might want to do it with scene depth. Oh, yeah, we might not care about outlines in the first pass. Let's just care about it in the second pass here. Scene depth, so what I want to do is we're gonna do float for outline data. Current point SS. Then we're going to do scene depth here. It's going to be equal to, I want to see if we get some difference here. Outlines data, we sample it, and then we do float scene depth VS is equal to linear I depth outline data dot G C buffer params. And if we use this one instead, and it's rough as fuck. Whoa. Why though? Yeah, because it's not the one we use in the first. Will it help us? Current depth seen. But this could very well be because, let's see here, current depth seen. Yeah, okay, this noise is definitely interesting. I think, okay, so basically when we do the when we write the depth to the outlines texture, so the outline depth, we write it like If we hit an outline, we write it to be equal to the depth value of the pixels that were closest to the camera when calculating if it were an outline or not there. If we don't have an outline, we just write the original depth. Unfortunately, this seems to mean that our rays are going to intersect a lot of things in the wrong place. I knew it would lead to some problem, but not as big as this. Definitely not. If we do a step length of 1, we still have quite a lot of noise. Yo, what's up, Fabic? How are you doing? Long time no see, man. Hope you're doing great. I had to think for a while. I haven't watched that much Top Gear, so I didn't know who Stig was. It kind of looks like it. I'm good. Nice to hear. Nice to hear. Same here. Same here. A little bit taken aback though. We're currently adding the outlines to the reflection. I knew it was gonna be, if I wanted them real good, it was gonna be quite complicated. But it also turns out that, like, if I lose the constraints of the visual clarity of the outlines, it's still quite complicated. We're getting some noisy reflection intersection data, which bothers me. We can start with the most crazy ones, these right here. I think, bam, bam, I think we're hitting the outlines here. For the outlines, we find this to be a hit, but not for the original pixels, right? Derek, you're gonna end up with one of the nicest looking SSR solutions out there. I sure as hell hope so. At least on the right side of the average, you know. If it's easier doing it wrong, yeah, maybe. In most cases, I would say that holds true. Thank you, appreciate it. Appreciate all the kind words. I'm pretty sure we're gonna get to the bottom of this as well. It's just a matter of what correction do we need to do? Let me do some drawing here. 256 for 14. How the hell should I draw this in a good way? We can do it like this. I don't know. So let's say that we have an object that we have an outlined object that goes something like this. So these are pixels, these boxes here. This box will be an outline. This will be an outline, this will be an outline, this will be an outline. This will be an outline, this will be an outline, this will be an outline. Probably not this one, but this one and this one as well. This object right here is close to the camera. The pixels that are not belonging to the object are far away. So that means when we write the depth to the depth texture, this pixel will get the depth of the pixel. So when we calculate this outline, it's this, 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 and this, and yeah, this and this and this, but yeah. So whichever of these pixels that are closest to the camera, and that is probably where we go wrong. Yeah, so currently we do whichever of these pixels that are closest to the camera, we take the depth value of that one and put it. So let's say that it's this one. So we take the depth value of this one and set this pixel's depth value to this one. This makes me wonder what happens if we have a foreground value that is not the outlined. Like what we're trying to do here is that like this outline belongs to this object, so we want this outline to have the same depth as this object basically. But I'm wondering, are we doing this the correct way? Let me return. Could I do fragment return, let's do float for a is equal to outlines sample ray dot start ss and then I want to return a.g, so the depth at that pixel. Remember, this depth is non-linear and it's one close to the camera, but we fix that here. I'm pretty sure. And you can see here the outlines. So this pixel right here, it has the depth of this character instead of the background. It's very hard to see here as well, but the same goes for this one. And yeah, you can see it here as well, but it's not as visible. So my question now is, how could this possibly mess up the reflection? This bad. Huh. Fabric, sorry for the confusion, but can you calculate / add the outline after the reflection / refraction as a last step of the shader? That's pretty much what we're trying to do, I would say. But there's a problem with, like, the outlines. They are not only on top of the object being outlined, they are also outside the object being outlined. So if we don't take the outline depth into account, we're gonna get reflections of objects, but only half of the outlines, if that makes sense. Sorry, miss a couple of this. It's no problem at all. It's no problem at all. Like I want people to ask questions. So yeah, the simplest solution would be that when we find a intersection with the reflection, that we just read the outline data as well and add that outline to the reflection. Maybe I will have time to show it today, but that will still only give us half the reflection. So let's do that first, and it will pretty much, or it will probably visualize the problem quite well. So let's do that. So let's remove that, back with that, remove this, and back with this. Almost. Okay. Best would probably be to show it here, I guess. And then we do sample reflection color. Here we calculate everything. We sample the reflection color here. So what we want to do here is float for outline data, outlines.sample, outlines point clamp point ss, and then we do float for reconstructed outline is equal to, we're gonna do if outline data dot r is bigger than 0.0, i.e. we have outlines at this point. Then we reconstruct it, so float for outline color RGB, outline color.a times outline data.r. And then we do reflection color is equal to blend this one, reconstructed outline, reflection color, and then we continue onwards. Oh, that's rough as hell, but it's still okay-ish. Fuck, that's extremely rough. That's way worse than I anticipated. I guess this is gonna be a problem. We want this at 1, but we want this one at... Yeah, this was a pretty depressing surprise, but I'm sure we can fix it. Oh, that's true. Oh. Hey, maybe. Okay, we have a decision to make. We have to redefine, or we have to define how do we want the outlines to work on reflections. Because if we take a look at this one is interesting because here we don't have any outlines at all. That's because it's probably this one. So when we go outside of this one and we don't find an intersection, or like we return these pixels, we reflect these pixels until we don't find an intersection and then we just stop. So we don't have an outline here. Do we want the reflected outlines to fully mimic the outlines here, or do we want to outline the reflections? Wow. 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 Yeah, Fabik, I know. Wow, okay, this problem grew tremendously right now. Thank you so much, Fabik, I appreciate it. The kind words, the donation, very much appreciated. Makes it easier to keep going, you know, when you hit big massive problems like this. It definitely does. Wow. You know what? Ooh, we could probably add I hate this. Best case scenario, the reflection leads us to UVs in the outline data. So what the data that actually creates our outlines, we could just recreate them from that. Would be costly as hell though, so I don't know about that. Remember the water flowing in 3-dimension problem? You solved it. That's true. That's true. You will solve this one too. Thank you again for the kind words. Appreciate it. Yeah, no doubt. I think we're going to get to an acceptable solution in the end. It's just that I thought this one would be pretty straightforward. Okay. I wanna see one thing here. This won't fully solve it, but let's see here, texture 2D. And this is a very costly solution, I reckon. But if we want to be very crazy, very crazy, we could do this. Yeah, 18 minutes to solve it indeed. What I'm gonna spend the last 18 minutes on is just collect as much data as I can, so that I hopefully can get back with a clear plan tomorrow. Outlines data. I think this is pretty insane, but we could do reflection color. I'm also going to disable the outlines. We could go insanely crazy here. And reconstruct some outlines, basically. If we just do it for intersection points, it wouldn't be too expensive. But still, and I wonder what will happen with artifacts like this. But it might be... It might be the way to go. That means that we would probably get outlines around this one and around this one. But probably the best outlines. This is one approach. Costly approach. It also means that when we reflect objects that don't have outlines, we don't care about them. We don't care about them at all. But then again, this would give us outlines on top of this one right here, but not on the other side. But that is probably not that big of a problem, I don't think. What the hell is happening here? Did we have this problem previously? Oh yeah, we need to do one check as well. When we reconstruct the outlines down here, apply foreground outline. Apply foreground outline. If this is true, yeah, we need to do a depth check here. That's it. We need to do. Fuck, these outlines are driving me crazy. I've been having plans of doing like a custom depth of field effect as well that takes the outlines into account. That's gonna be insane, but that's way into the future. But still, yeah, we probably want to do util outlines eventually, but we need to compare pixel UV, if or outline data.g is less than sample depth, scene depth, pixel UV. I think that's what we want to do. Okay, that's not what we want to do. Yeah, there we go. But okay, yes, so back to this one. Not this one, sorry. This one. Okay, let's say that we are fine with the outlines only appearing on the object on the reflections. I think we can be pretty okay with that. Then we could recreate the outlines here for objects that has outlines. It will add a lot of calculations, a lot of samples, but just at the end of the reflection and just for pixels that are outline adjacent. That's one approach. Fabric, have to go, Robin. Good luck and hope to catch you tomorrow. Thank you, appreciate the drop by, the kind words, and the donation. Have a great rest of the day, Fabric. Okay, so this is one approach. What other possible solution can we have to this? It's not only a question of performance either. It's also a question of how it visually looks. If we do it like this, we will 100% make sure that we have outlines, that we encase the reflections in outlines, so to speak. And if that's what we are after, I don't know if we have any other solution to do it. And if we were to do it this way, we could also reorganize some stuff. We can change around the cues so that outlines are done at the very, very end of things. Which is probably preferable. That would, however, maybe I'm gonna have to research it, but maybe there exists a very smart way to reorganize when and where stuff is being done, so that when we create the reflections, we write it to yet another texture, but we also write to the outlines data texture. But no, because then or pretty much every shader that uses reflection, every shader that uses reflection then is gonna have to take that into account, have its own shader pass that handles it. Okay, this is what we're gonna do. Tomorrow we're gonna add a file utility outline. We're gonna put calculating outline logic in it. We're gonna add some other methods to it as well, like reconstructing outlines. And then we're actually gonna call that function from our reflection, so that we pretty much recalculate outlines for reflections. We're gonna see what kind of performance we get, what kind of visuals we get, and make a decision from that. But not only that, I'm gonna think about some other approaches we have to this problem, some other ways we could tackle it that won't yield the same visual result, but hopefully still a good enough result. And we also, I don't really like saying this, but we also have the option of doing outline, like doing reflections without outlines. We could probably get some nice visuals from that as well. So that is definitely also a solution. Probably the best solution would probably be to try and get the best possible outlines we can get on the reflections right here, no matter the performance cost. And then we compare that result with outline reflection without outlines, and then we just see which one looks better. Yeah, I think that's what we're gonna do. Yeah, so we're gonna continue this reflection outline adventure tomorrow because I gotta run, but I think it's been a productive session. I'm trying to not let this problem with the outlines put me down. Yeah, I'm sure we will solve it eventually. Yeah, thank you so much for watching, and have a great rest of the day. See you kids indeed. Peace.